Chapter 6, Conversions between measurement systems. We have one keyword, a measurable amount, the quantity of medication that can be most accurately measured with the device available. When converting between two measurement systems, the answers will not be exact due to the differences between the measurement systems. Other factors include the viscosity of the medication and the size of the devices used to provide the medication. Let's get past the pretest. So chapter 5 covered conversions within the same system, so within the household metric and apothecary systems of measurement. Each of these is used today in prescribing and administering medications, although the metric system is the most common. Because all three systems are used, conversions between the systems must be covered in detail. The two other units used in dosage calculations, milliequivalents, and units are rarely converted because they are unique to individual medications. If a physician writes an order in the apothecary system and the medication is available in a metric dose, you need to convert the apothecary dose to an approximate metric equivalent to ensure that the patient receives the correct amount of medication. Conversions from the apothecary system are approximations and may incur dosing variability. As the metric system becomes more widely accepted, the need for conversion will decrease, although the need to calculate a dose in household measurements will remain as long as the United States continues measuring in household equivalents. Household measurements use common measuring tools found in most homes. Therefore, for the person taking medication to be able to use readily available utensils, you may need to convert orders written in apothecary or metric systems to household measurements for ease of drug administration. Household measurements are more accurate when using actual measuring spoons as opposed to flatware, so like using your teaspoon and your tablespoon. However, it is appropriate to dispense a measuring device to ensure accurate dosing in the home environment because people may use their own flatware, which varies greatly in measurements. Conversion factors are equivalents between two measurements, whether within the same system or between different systems. Each part of a conversion factor includes a value and a label of measurement. The value of a conversion factor is always 1. It is used to change one unit to another without changing the value of the original measurement. Table 6.1 lists common conversions, metric, apothecary, and household systems of measurement. So this is also a nice little chart that kind of just shows you the different equivalencies. So we have volume and mass and weight and then length. So as you can see from table 6.1, the apothecary grain has a range of equivalencies. The conversion between grains and milligrams actually varies between different medications. Table 6.2 illustrates some of the more common medications that are still dosed in both grains and milligrams. This illustrates the degree of approximation between these two systems. Because the measurement systems are not identical, any conversions between them are approximations. Another example is that a dram is often used as a symbol for a teaspoon when a dram is actually about 4 ml, and a teaspoon may measure either 4 or 5 ml depending on the device. So table 6.2 shows the common medications dosed in grains and milligrams. So codeine, sublingual nitroglycerin, phenobarbital. We use a conversion factor of 60 milligrams per grain. And then aspirin, acetaminophen, and ferrous sulfate, we use 65 milligrams per grain. The conversion of 20 drops per 1 ml is based on a viscosity close to that of water. Remember, the number of drops varies according to drop size and thickness of the liquid. This conversion is not used in dosing because medications used in drops come with a specific dropper for administration. It is mostly used for determining day supply with eye drops or eardrops for submission to insurance companies. All right, if one factor is in one system, such as the metric system, and the other factor is in another system, such as the household system, you can use ratio and proportion or dimensional analysis. Some points to remember: set up the conversion ratio with the known conversion units on the left of the equation. Set up the second ratio of the proportion within the conversion units for the unknowns. Label the units so the like unit is placed in the same position with each ratio and proportion. This sets the ratios so that they are equivalent to each other. Cross multiply and divide to solve for the unknown. So we'll do example 6.1.
All right, so example 6.1 and 6.2 are the same problem. They just, one of them is going over it using ratio and proportion, and the other one is using dimensional analysis, which in our program we use proportions. So, in ratio and proportion. So, that's how I will do these two examples. So we need a conversion factor between milliliters and teaspoons. So if we go to our chart, we should see that 1 teaspoon is equal to 5 ml. Now we have 10 ml. How many teaspoons is that? So we're going to start off with our x. 5x is equal to 10 times 1, which is just 10. So we have 5x equals 10. We want to get x alone, so we need to get rid of that 5. So we're going to divide this side by 5. That makes that cross out, and we have x left. We also have to do the same thing to the other side. So 10 divided by 5 is 2. And the answer is x is 2 teaspoons.
So conversions between household and apothecary systems. The apothecary system has only a few significant measurements that, although not commonly used, do convert into household measurements. Of importance are minims to drops, drams to teaspoons, and ounces to tablespoons. Cups, pints, quarts, and gallons are used by both systems. Length is not measured in the apothecary system. All right, so we'll go ahead and do example 6.3.
Okay, example 6.3. We have 3 fluid dram equals how many teaspoons? So if we go to our conversion sheet, looking here, we have 1 teaspoon equals 5 ml, which equals 1 dram. So we can pull anything out of this conversion factor, any two things out, because they're all equal. So we're going to take out 1 teaspoon equals 1 dram. And we have 3 drams here. How many teaspoons? So we would do 1x, which is just x, and then 1 times 3, which is just 3. So our answer is x equals 3, and that makes sense because if we have 2 of the same numbers on this side, we have to have 2 of the same numbers on this side, and we do. So our answer is 3 teaspoons.
Conversions between household and metric units. Most conversions from metric to household, such as milliliters to teaspoons or ounces, are volume conversions, although length from inches to centimeters is sometimes used in the medical field. So a little illustration of the equivalence between household and metric measurements. And we'll go ahead and do example 6.4.
Example 6.4, we're going to use the conversion factor of 1 ounce is equal to 30 milliliters. We have 60 milliliters. How many ounces is that? And hopefully you can look at that eventually and see that that is an obvious answer. If we already have 30 ml is 1 ounce, then 60 ml, which is exactly double, our answer is going to be exactly double. But we can figure it out by going 30x is equal to 60 times 1, which is 60. 30x equals 60. We want to get x alone. So we need to divide both sides by x. 60 divided by 30 is 2. So answer is 2 ounces. Example 6.5. Because most of us do not know how many centimeters are in 1 foot, this is calculated more easily as a multi-step dA equation using 2 familiar conversion factors. So you can see how they did it here. You do not need, you can just do 2 separate ratio and proportions, but you shouldn't see anything like this, maybe just going from inches to centimeters, not going from feet to centimeters.
The metric system uses grams, liters, and meters, whereas the apothecary system uses grains, minims, drams, and ounces. When converting between two systems of measurement, the equivalents are approximate. So we have a mass and a volume chart here. And again, remember, these are approximations, not exact numbers. We'll go ahead and do example 6.6 now.
Example 6.6, 15 milligrams to grain. So we have the conversion factor of 1 grain is equal to 60 milligrams. And we have 15 milligrams. How many grains is that? We have 60x is equal to 1 times 15, which is just 15. We want to get x alone, so we need to divide both sides by 60. And we get 0.25. But remember, this is the apothecary system, so we need to have our answer in fraction form. So hopefully you know that this is 1/4. If not, you can do a long division problem. So that would be the answer to 6.6. All right, example 6.7. So we're going from 1/100 grains to milligrams. So we're still using that 1 grain is equal to 60 milligrams. We just need to deal with that 1/100 and make it into a decimal because it'll be much easier for us to work with. So 1 divided by 100 is 0.01. So that's 0.01 grains. How many milligrams is that? All right, so we'll do 1x, which is just x, is equal to 0.01 grains times 60. Which gives us 0.6. So 0.6 milligrams.
So this is a nice little chart to have on sublingual nitroglycerin. It has the grains, so 1/200, and then the milligrams, and it shows how they got that answer or got all this information. Same here. And the methods of conversion between metric, apothecary, and household systems have been presented. Conversions between measurement systems are approximations, and some will vary depending on the conversion factor used, such as the number of milliliters in a dram. The metric system is the most appropriate and accurate method of measurement, and therefore is used exclusively when compounding prescriptions and making intravenous preparations. Conversions within and between measurement systems may be accomplished using either ratio and proportion or dimensional analysis. Once you learn the basic equivalencies listed in table 6.3, you should be able to accomplish almost any conversion needed in the pharmacy setting. So we have the household liquid measurements and volume, weight, dry weight, metric volume, and household and metric conversions. Then we have the apothecary system volume, the apothecary system weight, approximate conversions, and the miscellaneous.